Good morning, all of you. Today we will start our next topic, Poisson distribution. Previously, we have discussed binomial distribution, which is a discrete type of distribution. Now, the second case is your Poisson's distribution. It is also a discrete type of distribution. In this case, the number of trial and the probability of success are varying in this way. It is also same as binomial distribution, but in this case the probability of success is very small as compared to the number of trial, that is n is very large, and as compared to this p is very small, that is your n tends to infinity and p tends to 0. So n into p will be is a finite value because n tends to infinity and p tending to 0. So np is a finite value, and let that finite value be lambda, say. Then we get the Poisson's approximation to the binomial distribution. You know that it is your binomial distribution, and Poisson distribution is the limiting case of binomial distribution when n tends to infinity, which is given by the formula lambda to the power r e to the power minus lambda by r factorial, where lambda is equals to n into p. Lambda is the parameter of this distribution, which is given by lambda is equals to n into p, where n is your number of trial and p is your probability of success. And this is the formula for Poisson's distribution that you have to remember. The mean of Poisson distribution is mu is equals to lambda, that is your np. Mu is equals to np, and variance is also np. In case of binomial distribution, variance is your npq, but in case of Poisson distribution, variance is your np. This is the difference. Because p is very small here, p tends to 0, and all of you know that p plus q tends to 1. Agar p tends to 0, then q tends to 1. So it is np into q is your 1. So this will be np. In case of Poisson distribution, that's why variance is your np also. Now we will discuss some numerical based on this topic. Now let us calculate another numerical. Assume that the probability of an individual coal miner being killed in a mine accident during a year is 1 by 2400. 1 by 2400. Use Poisson's distribution to calculate the probability that in a mine employing 200 miners, there will be at least one fatal accident in a year. So what are the data given here? P is your probability of getting the accident. That is your how many number of chances of a miner to face an accident is your 1 by 2400. So P is equals to 1 by 2400. Here no need to calculate Q because we have no need of finding the probability of failure. And n is how much given here? N is equals to 200 because there are 200 miners working in the company. So n is equals to 200. So what is the value of lambda here? Lambda is equals to np, that is equals to 200 by 2400, that is 1 by 12. So now what we have to calculate? Probability of x is equals to r, that is your m or lambda. It may be lambda, it may be r. Lambda to the power r e to the power minus lambda by r factorial as per your formula. This one. So put the values of lambda. Lambda is how much? Np. Np is your 0.083 that you have calculated previously here. So put the values. And now what you have to calculate? Probability of at least one accident. Probability of at least one accident. At least one means it may be 1, maybe 2, 3, 4, 5, 6, up to 200. So it is very difficult to calculate this one. We will calculate this in a complementary way. That is 1 minus probability of no fatal accident. Okay, so probability of no fatal accident, that means probability of x is equals to 0. First you calculate this one, then take its complement, that is 1 minus probability of x is equals to 0. So what does it mean? Here r value, just in the Poisson distribution, put the value of r is equals to 0. In this formula, put r is equals to 0. That is your 0.083 to the power 0 into e to the power minus 0.083 divided by 0 factorial. That is your 1 minus 0.92, that is 0.08. Let us consider another numerical. On an average, 1 in 400 items is defective. If the number of items packed in a boxes of 100, then what is the probability that any given box of 100 items, here it is missing, any given box of 100 items will contain no defectives or less than 2?